How was your weekend?
It was okay. And yours?
Mine was good. I had to work, but I did my homework.
Oh, good. Any questions?
We got different answers for some of the stuff.
Yeah.
I
Well,
you both gave each other the look.
so like when my triangle goes up same direction as my I hat J hat direction, so it's supposed to go this way. So is my I hat supposed is my J hat, which is the
Wait,
vertical?
is this the thing coming off the ramp?
Yes.
Okay.
So is the J hat supposed to be negative or positive? Or
Whichever you set up.
so
I don't
like
think I specified, did I?
yeah, you did, but like I don't. So but like the ball's going down.
Yeah.
So is the vertical supposed to be negative if my J hat is going up for my origin
Yeah,
origin?
then the vertical component of the velocity would initially be negative, and acceleration would be negative, and displacement would be negative also.
So it's just a minus then.
Did I have to go get that one right? Is that where you two different?
The minus for the, are you talking about for,
Initial.
If up is positive, then for the ball coming off the ramp, then initial velocity is negative, acceleration is negative, displacement would be negative.
yeah, I put minus and you put plus,
Yeah.
didn't you?
Yeah, and then for the horizontal, it's just positive because you're going from left to right, and that's the direction of my positive I hat, which is from left to right. Okay.
Yeah.
Where are your office hours? Are they in this room?
No, in my office,
I knew that.
which is, you walk down the hall and take a right
Oh. Did you
before you
have,
get to the elevators.
did you have office hours on Friday?
No. We had the pleasure of being in,
Yeah, I did hear about that.
The what? Thank you.
we were meetings all day.
Yeah,
Oh.
from like 8:30 until like 4.
Sounds like.
Yeah, closer to 4:30, but,
I'm somewhat happy about that because I didn't have school.
yeah,
Why are you this?
it was good times.
There's Friday on there,
Yeah.
and it always trips me up, that's why. I thought the test was on Thursday, we're good.
This is on Wednesday.
That's terrible.
At least it's not today.
What?
I said, at least it's not
Yeah.
today.
Oh, I thought you said you wanted today.
That's what you wanted.
Thank you.
What have you seen?
You made it bigger.
You put Monday, Tuesday, Wednesday, Thursday, and one card in.
The test is on Wednesday.
All right. Other questions?
What's the next test after that?
Make it bright.
While she's doing that. Now, people have no idea, since you were off camera, will have no idea what you just did.
Turn it right quick.
Any questions? Or other questions?
Probably so.
Can you, from last class, we went over the friction, like how to, like when you're solving, when there's friction involved, can you go over that again? I don't think I got it.
Okay, we'll definitely do some friction stuff today.
Oh.
Any other questions about the past? Yes, I guess I was the past.
The future, do you have any office hours? Sorry, that'll.
Any office hours with?
Do you have any office hours today? Like,
You had them.
In the morning.
Yeah,
it's up in the
they're in the morning. My office hours should be correct.
No, you
on-
say it.
dude, I had no idea they weren't in this room. I'm pretty sure I
Yeah,
asked
they're
Robin,
not.
and Robin
Yeah.
said, in the classroom.
Oh, my bad.
So I come here at 9 a.m. and no one was here, the door was locked, and I just went and sat downstairs.
Okay, if you had yelled my name, I probably would have heard you.
Are Are you serious?
He doesn't have one on Wednesday though. I checked it.
It's not that far.
Do you have them tomorrow morning?
Yeah,
Tomorrow, Tuesday is from 9:30 to 10:30.
Okay, cool.
I'm there every day.
I'll see you in the morning.
Mondays from 8:30 to 9:30.
That's too early.
It's just-
I can't do that.
It's before this class, Monday, Tuesday, and Thursday.
Mhm.
Wednesday, I don't officially have office hours, and
You know,
then
we
Friday,
should-
I've got 2 hours of office hours
Okay.
from,
Yeah.
You
know
just
what?
borrow the classroom.
Yeah,
you
I
know,
should
like-
borrow- there's someone in here at like 8:30 in the morning.
Yeah,
I
no one
checked.
was in here.
I should check like 7:30 in the morning. There's
So will
someone
you
here.
be in your office tomorrow at 9:30?
yes, I should
Okay.
be.
You should. Okay.
I've got class before that, so
What time is your class in the morning?
I have an 8 o'clock class on Tuesday, Wednesday, Thursday.
Is that the 16th week?
Yeah.
Yeah, it's 16.
It's a
I almost
151.
took that one and I was like, I don't think I can be at class 8.
I was wondering what the deciding factor was for some people.
I was like, I don't think I can.
I wanted to take that one.
I wanted
But
to.
I don't wanna take 16-week one.
Me,
So
because
like these were flipped, 100% would have done that.
Yeah.
my friend is
I
taking
was
the
Then I
one.
could have the rest of my day, do whatever. This class ends at 12:20. It's so long.
I
It's
know.
it's like a 3-hour class.
Well, I'd rather have this one than have a Friday class in here.
I could
Wait,
never
do you guys
have-
have the Friday class or is it just till Thursday?
No,
Say
that
it
one
again?
is only 3 days a week.
Do you have a Friday
Oh.
class?
But
I have a
still,
Friday
3
back.
days a week for 16 weeks or 4 days a week for 8 weeks.
Yeah, I just wanna.
You're just getting one extra day.
Yeah.
Might as well just do 8 weeks and quit.
But at the same time that you get is, I don't know. I mean, my friend is still struggling, so.
I feel like we're all struggling.
It's part of it.
Oh, it's fine.
All right, so I think your question was answered.
Yes, thank you.
Are there other questions? Okay. All right, there's questions to do some friction stuff. Let's start out with the classic box on ramp. And hopefully a marker that is darker.
You know, you
than
throw
that.
one away every class and
What?
you chuck it.
Yeah, well, I mean, there's still
It's my
some
favorite
life.
part of the day.
In the other classroom, Assassin had a box that said markers that have angered Dr. Fox. Some days I just miss chalk. All right.
No way.
No, I
I
don't
feel
like
like Trump was even
Giving
easier
it
to
on my
see too
fingers
as
would have had a
well.
problem.
Chocolate Lisa worked.
Oh,
and it
sour
worked.
throws me off.
No, but like, I used
Yeah, you're
chocolate
right.
once in
All right,
elementary.
so thoughts on ramp, let's say use of S is 0.8, use of K is 0.5. Let's make this a 30-degree angle and make this a mass of M. Now, if on a test or quiz or something like that, you are not given the exact mass, it means one of two things. It means either, actually, one of three things. It means I want the answer in terms of letters, no number at the end. Or the mass is completely irrelevant, or I made a mistake. I think we showed last time that the mass is completely irrelevant, so if you're ever in a situation where it's really throwing you and I didn't give you the mass and it was not a mistake on my part, then make one of them. Not 0. One is usually convenient mathematically in whatever units you want. All right, so I've got my 30-degree angle here. And first, let's start out, just do force diagram. Oh, initially starts at rest. And, oh, what the heck, let's make it the vector version. Doesn't change anything. All right, so we have friction on the ramp, and that's indicated by the fact that I got a US and a UK. We need to determine if it's going to move. So let's start out the same way we start out, regardless of whether it's going to move or not, with, well, the facades method. What's the first step?
Force diagram. Friction. No, are we drawing already? So friction goes to the left. No, like it's like on the angle of the left, so like it's on the.
Up and to the left?
Yeah.
Can you draw the ramp on
Sure. For what? Ultimately, I only care about this. The ramp, we assume, is attached to a planet.
Okay.
So the ramp is not going to move. We assume that any movement that the ramp will not move independent of the Earth. Excuse me. We will assume that any movement of the Earth is insignificant. So friction acting up back that way. Now, was your request whether it was okay if you added the ramp, or do you want me to add the ramp up here?
Both.
Okay. It's okay if you do or don't on this particular problem. So where's the other part of that? They come in pairs.
On the right, to the right.
Okay.
Gravitational.
Okay. Acting which way on what?
Downward on the ball or the object. And upward on the normal force. Because it's touching
Okay. Acting which way?
that way. And then northeast that way. Thank you.
Now, if you're going to use the pencil as to point in a direction, I appreciate what Laura just did, is she just did that. Sometimes people will go, it's going in that direction, and I'm going, all right, which way is that? So you did not do that, so thank you. All right, so there you go, fourth diagram done. Acceleration. If there is going to be acceleration, which way will it accelerate?
Downward. So
Okay.
downward parallel to the
Southeast.
ramp.
Southeast.
And again, I'm drawing this far enough away, and I'm hoping to indicate this is not part of the force diagram.
The acceleration.
Coordinate axes. Sorry, what's next?
Coordinate axes.
And how do you want to set those up?
The I hat's parallel to the acceleration, and J hat is perpendicular from I hat.
Okay, we've got some choices there.
What? Oh,
There's-
the J. That's the first one is I hat. So the second one is J hat. So it's gonna be perpendicular to the I hat.
Yeah, let's be more specific.
Oh, positive.
Right hand
Sorry, okay, do I tell people going this way? Now, you do have 360 degrees of freedom here. I will tell you that if it is not in the plane of movement, it's probably not gonna help you a whole lot. But J hat, either in the direction of the normal force or opposite direction of the normal force in this particular case. All right, what's next?
Decomposition.
What are we decomposing?
The weight.
All right, so we're gonna break that up. So I got W sine theta down the ramp, Y, W cosine theta. Sorry, I should have asked. W sine theta or W cosine theta down the ramp?
Sorry.
Kiss you, sir.
Yes, it would be.
Right there.
For the reasons laid out last time, I can set that triangle up again if there's a desire to.
Sure.
Wait, what?
I got a sure and a no, not really, okay. How do I know that's sine and that's cosine? I will tell you, if I know the angle versus the horizontal, then it's gonna be the sine going down the ramp. But breaking it up, there's a pen. So in essence, that is the vector I'm breaking up. Weight is acting straight down. I know that I'm breaking it up into perpendicular components. One of the components is parallel to the ramp, the other is perpendicular to the ramp. So I am trying to figure out what that is and what that is. The one other, I know this is weight. And one other piece of information I have here is I know that that angle there is theta. There's several ways of going about this. Again, perpendicular, right angle. What do I know about the angles? The three angles add up to in a triangle in Euclidean geometry?
180.
Okay. Did somebody just, thank you. Well, 90 of it's taken up by that angle there, so this has to be the complement, or 90 degrees minus theta, which I will label as theta prime. It's officially define it. This is my notation, it's not typical math notation. I know weight is also acting straight down, and my angle here is versus the horizontal, so I know that is a right angle there. What's the angle of a straight angle?
180 degrees.
Thank you. Well, 90 of it's taken up right there, so this part right here must be the complement of theta prime, which is just theta. So now looking at this triangle here, this is opposite my angle theta, so it would be associated with the sine. So hypotenuse times the sine of theta, hypotenuse times the cosine of theta. There it is.
And that's what when you would ask for decomposition, you would draw, that would be the answer, that drawing.
That would be the way of getting to the drawing. I mean, ultimately, that's the answer right there.
Okay.
I do want to point out that when I put on W sine theta and W cosine theta in my force diagram over there, I did not write W also. I have some students who will, at this point, they'll then have W sine theta, someone will write W cosine there, W cosine theta, and W all in the same diagram. These two are replacing the W. The sum of these two is equal to the weight. So technically, it should be, I've got the components or I've got the sum. All right, questions up to here? Before we get to E, let's take a look at this slightly differently. I know that F equals NA. So if I have my ramp right there, I know that the sum of my forces should be pointing downwards, if anything at all. So if I start here, I have Y, I have W, and then I have friction. And I'm gonna draw that bigger. So my normal force is perpendicular to the ramp, so now I'm here. I add the weight to it. There should be my weight, there's my normal force, my friction. And so the sum of those should be equal to the mass times acceleration. So the sum would be a vector from where I began to where I ended. That should be equal to the mass times the acceleration. That's my total force right there. So adding these vectors together, so adding them graphically is another technique of doing. It's not as accurate as using trig, but it is, for 110, I have a version of the Newton's second law lab, where they do this in order to find the friction. All right, so back to what are the equations of motion? Now that I've broken it up. We're at the E part.
So for J hat,
Okay.
it's normal force minus weight times cosine theta equals mass times zero.
Yep. Going for mass minus 0. Right?
And then for I hat, it's it'll be sine theta minus friction equals mass times acceleration.
Okay. If I'd stated initially there was no friction at all in this problem, then we still could have gone about this the same way as we're doing here, just but leaving the F off, or we can do this assuming that there is friction and now set the F equal to 0 if we need to do the frictionless case. So we have our two equations of motion because I have one object with 2 dimensions worth of forces, so that part is done. So now the first S. What is the first S?
Substitution.
Yes. Okay, so for which of these do we have an independent formula? In other words, a formula that is not specific to this problem. Yes. What is the formula for weight?
Mass times gravity, gravitational force.
Acceleration due to gravity.
There we go. Or just shorten it to mg. All right, so I have y minus mg cosine theta is equal to 0. And mg sine theta minus f equals ma. All right, do we have any other